Hi, this is Mr. Snyder with Truman Middle School, and this lesson is over Chapter 7, Section 8 on symmetry. And our objective is to learn, identify symmetry in figures. Our vocabulary for today's lesson is line symmetry, line of symmetry, and then rotational symmetry. So those will be the things that we will be talking about and defining as we go along. In nature, you will always find many examples of symmetry, such as butterfly wings, the petals of a flower, many things out there show symmetry. And remember, symmetric objects have parts that are congruent. A figure has a line of symmetry, and that is kind of the cutoff between the two congruent sides. So if you fold it across the line of symmetry, you would match up side to side or congruence to congruence. So a figure has line symmetry if you can draw a line through it so that the two sides are mirror images of each other, and this line is called the line of symmetry. If you fold a figure on the line of symmetry, the halves match exactly. So a lot of our examples today will be just really kind of testing your artistic ability to see if you can draw mirror images of the shape. So here we have a horizontal line of symmetry and we have the top half of the shape. So if I wanted to draw a congruent figure, I would simply trace the same figure, just a mirror image of it on the bottom side. This one has vertical symmetry, so to make the other side congruent, I would simply trace the left-hand side exactly as the right-hand side is drawn. In other words, the mirror image. So again, we would draw that and it would look like a crown. Even curved lines, squiggly lines, they can have symmetry as well. This has a horizontal line of symmetry, so I would simply just try to match that up as best I can by drawing the lower half of it. This looks like part of a barn, so to match the symmetry of this one, I would simply draw a figure congruent on the left-hand side to the one on the right-hand side, like so. Rotational symmetry is a little bit different. A figure has rotational symmetry if you can rotate the figure around some point so that it coincides with itself. The point is the center of rotation, and the amount of rotation must be less than one full turn, or less than 360 degrees. So generally, you can see if things have rotational symmetry just by counting their points or their corners. For instance, the snowflake, it has 6 points, comes to 6 points, so there are 6 ways I could rotate it and it would coincide with itself or look exactly the same. I could rotate it 1 click to the right and it would match up, 2 clicks to the right, and so on. So it does have 6-fold rotational symmetry. This larger snowflake has 8 points, so it would have 8-fold rotational symmetry. 6-fold and 8-fold rotational symmetry just mean that the figure coincides with itself 6 times for the figure on the left and 8 times for the figure on the right for one full turn. So usually when I'm calculating symmetry, I physically rotate the object. I hold it up and rotate and see how many times it looks like the original object. So that's kind of a, I guess, a good strategy for solving these problems. If we want to draw rotational symmetry, I would simply follow the directions. They want to show 2-fold symmetry, so I would rotate this figure 180 degrees. And if I rotate it 180 degrees, instead of being an L upside down, standing on its head, it would be an L kind of sitting naturally, like so. For figures that come to a point, if they tell me they want 5-fold symmetry, that means it's going to need to come to 5 points, similar to a star. So I could simply draw 5 of these diamonds, and I would end up with a star like so. And there's 5 different ways I could rotate this. So that means it has 5-fold rotational symmetry. For 8-fold, think of a flower. This would be 1 petal. So to make 8-fold symmetry, I would simply draw 7 other petals, and the complete picture would look like so. So now this has 8-fold symmetry because there's 8 different ways I can rotate it and it looks like the original object. 10-fold, for this diamond shape, I would simply draw 10 of these diamonds. So it comes to 10 different points, in which case I could rotate it 10 different ways and it would look similar to each other. So that's pretty much it. Rotational symmetry is just being able to rotate a figure so that it matches up with itself, and you would simply count how many times it matches up with itself. And regular line symmetry just means tracing a mirror image across the line of symmetry. And that's all. That's all we have for you today. So good luck with your homework and email us if you have any questions.